right. It's on, there it goes, it's in focus. So we're going to talk about three forms of linear equations. And the focus today is going to be how to graph these three forms. So slope-intercept form, what is that? Very good. Y equals mx plus b, where m is the slope and b is the intercept. And so if we have an equation like y equals 1/2 x plus 2, the way that we typically graph that is by looking at our intercept plus 2 and making that our first point, and then using our slope 1/2 to get the next 2 points. So I'm going to go up 1/2 and put a point, and then go up 1/2 more and put a point there. And assuming I did that nicely enough, which I almost did, those will all line up on one nice straight line.
They use the yardstick. That's the reason we don't hold them make one.
Okay, so this is slope-intercept form. That's how you graph it. That should be review for everyone. Now point slope is going to be review for some of you. It's going to be new for some of you. So I'm going to go over this one a little bit more slowly. What is point slope form? Y, maybe it's new for everyone. Y minus y1 equals m times x minus x1.
Yeah, we never learned that.
Okay, so this is new for everyone. So, point slope. Not my favorite type of line. I mean, they're all the same, they're all lines, right? There's only one type of line. Not my favorite equation. I don't think you see this one quite as much, but it's when you have something like this. Let's do x.
Wait, so where did the one go?
So this is what's going to happen with this form of the line.
What's the dot?
You're going to use the point to start your graph. Okay? The point is this negative, comma this negative. So it's the opposite of this and the opposite of this. Yeah.
What do the dots mean?
What dots?
They're like near the Y and the X.
Up here?
Yeah.
Oh, so the way you would read this is y minus y1 equals m times x minus x1.
Oh, wait. Is it because those two go together?
Yeah, and so what's going to happen, the x1, y1 is our first point on the graph. So in this example, our first point would be negative 3,
No.
2.
Wouldn't it be the opposite?
Uh-huh, it is the opposite, right? So here it's a plus 3, so the point is going to be minus 3. Okay?
Okay, good.
And then here it's a minus 2, so in our point it's plus 2. So we don't start on the axis in this form. Right? We start at some random point according to our graph. Then m is the slope. So now it's the same process as slope-intercept form.
The upgrade.
It's the exact same. I go up 3, 1, 2, 3, over 5. 1, 2, 3, 4, 5. Okay, and then I could do that again. I'm not going to right now. And I would make a very nice straight line that goes on in both directions for it. So this is the graph of this equation. Starting here at negative 3, comma 2. And I got that from this and this. And then going up 3, right? Up 3 and over 5 because of my slope. So these are a little bit, like slightly harder to graph than slope-intercept. Right? The only thing that's a little harder is you have to look at that y1 and that. Yeah.
How did you get
I get it.
a negative 3 instead of negative 2 if it's x plus 3?
Right, exactly. It's the opposite of that. So this is plus 3, so my point is going to be minus 3.
You just have to remember
Okay?
it's always
This is minus 2, so this one's going to be plus 2. So you have to remember it's the opposite of what's in the equation. The reason for that is watch what happens if I plug this in. So if I have this equation, y minus 2, according to this point, it would be 2 minus 2. That's going to make 0. Right? So that's why it's opposite, because what we're doing here is making 0. And then we have 3/5 times, now it would be negative 3 plus 3, which also is going to make 0. So I have 0 equals 0 at that point. So what I'm trying to do is make this 0. And what does that is when y is 2, not when y is negative 2. So it's the opposite of this and the opposite of this. Okay? Let's do another example of that. So, what if I had y minus, let's do y plus 1 equals 3x minus 2. Okay, so graph that equation. Where are we going to start? At what point? At 2, comma, negative 1, right?
So you're going back.
So our point is 2, comma, negative 1. That's where we start. Right? The negative 1 is the opposite of that. The 2 is the opposite of that. So 1, 2, negative 1. Where am I going to get my second point? How am I going to find it? Look at that slope. Yeah, imagine that's a 3 over 1. So I'm going to go up 3, 1, 2, 3, and over 1. So my point is right there. And this line is going to be, well, my points are pretty horrendous. But
It's going to be up 2 first or down?
this is going to be a steep line.
Wait, and I want to be so you're going up 2?
No. My first point is 2, negative 1.
Yeah.
I get the 2 from here. That's the opposite of negative 2.
So you go
I get the negative 1 from here. That's the opposite. That's my point. I graph that point. 1, 2, negative 1. That's right there, right? This is my starting point.
Oh, okay.
That's the only step that's different from slope-intercept form, right? The next step is the same. I look at my slope, m, and my slope here is 3. So it's an imaginary 3 over 1, because 3 is 3 over 1. And so then from this point, I go up 1, 2, 3, and over 1, and I end up right there for my second point.
That's a long ways away from
Up 1, 2, 3, over 1. From here. From the place where I started.
up 3 over 3.
No.
Because that dot up there is far away.
No, it's this dot is right here.
Oh, okay, I see.
I'm just going over 1 to there. I'm starting at this point right there, okay?
Yeah,
So I'm starting here and going up 3
I see.
and over 1.
Oh,
So I'm not at 3, 1. That's not where I end up.
I see.
I end up at 3, 2.
I was thinking of going along the line.
Okay, questions about point slope? Other questions about point slope? Alright, standard form is totally different. This is just like, forget everything you just learned when you see a graph that's in this form. AX plus BY
Why do they call it
equals C.
standard?
Every equation of every line can be written in standard form. That's not true of the other forms, right? If I have a vertical line, it's impossible to write it in this form or this form.
What about that?
You can write it in this so that's kind of why it's a standard form. It can express any line. Now, this one is a little bit more complicated to graph. So what we're going to do, if we have something like 2x plus 3y equals 6, here's our procedure. What we're going to do is find 2 points. Those 2 points are always going to be on the y-axis and the x-axis.
Make the other one.
Right. So I'm going to start out by making, let's make x 0. So I kind of cover that up. When x is 0, so x is 0, then we have 3y equals 6. What is y in that equation? 2, because 3 times 2 equals 6. Or because 6 divided by 3 equals 2. And so my y is 2. Then I make y 0. And I have 2x equals 6. Divide both sides by 2. X equals 3. And so x is 3 when y is 0. The really important thing to remember about this form, my point is not 3 comma 2. Right? That's the most common mistake I see people make. They try to do this really fast and they go, x is 0, y is 2, y is 0, x is 3, so 3 and 2, and then they put a point at 3, 2. No, not at all. When x is 0, y is 2. So the point is right on the axis. Your points will always be on the axis when you're using standard form. The other point, 3 comma 0, is right here. And that's it. You don't use the slope in this type of graphic. Okay? So I'm just going to connect those 2 points and make a line. Cool. It is cool.
It's easier than point slope.
Yeah, some people think some of these are easier or harder or whatever. The key is just to remember these kind of steps. These are like tricks for graphing, right? You could graph any of these using a t-chart as well, right? I could give you an equation like this, and you could say, okay, actually that's really what we're doing in our heads. What we're doing is we're saying when x is 0, y is 2. When y is 0, x is 3. But you could pick anything and graph it that way. So I could graph this, maybe I want x to be 1. When x is 1, I have 2 plus 3y equals 6. Subtract the 2, 3y equals 4. Y is 4/3. This point is a lot harder to graph than this one. And so these tricks are just going to make it a little easier for you to graph these lines quickly. If you ever get stuck though, try just using a t-chart. It will always work. 100% of the time for graphing. You can always use a t-chart. Okay? You can graph anything just by using a t-chart. I could give you like a super complex equation. Y equals x cubed plus 7x squared minus 1/3 x plus 2.5. And you could figure out values of x, put them into a t-chart, and get the value of y, and you could graph it. Right? It wouldn't be very fun. It would take you a long time. But you could do it if you wanted to. And so these tricks are just helping you to remember what these graphs are supposed to look like and what are some key points that are easy to pick as you go through your graphing. Okay? There's nothing magical about what we're doing though. Right? It's just a shortcut or a trick when you see x and y on both sides. Alright. So, let's just quickly look back at these. How do we know an equation is in slope-intercept form? It starts with y equals. Okay? So if it starts with y equals, chances are that's slope-intercept form. How do we know an equation is in point-slope form? Sure, you have y and something else. Now, there is a trick to that. What if the y1 was 0? Right? So you could have an equation like this. Y equals 1/2
Because that's
x plus 3. This is still more point-slope form than it is slope-intercept form, isn't it? So point-slope is the one with these parentheses. Okay, that's going to help you, I think, a little bit more. When you see these parentheses, you know you're in point-slope form. And then how do we know we're in standard form?
It's a random number and x and y equals.
Yeah, so on one side of the equation, you have just a number. That's how you know you're in standard form. All right, let's practice this. Yeah. Could some